In this module, I introduced the concept of Boolean expressions. What is a Boolean expression, I hear you wonder? Well, it is a little difficult to describe with words. So what I'll do is I'll show you a code sample, and then we'll take the conceptual explanation of that from there. Here is age5.c, which I've created just for the purposes of showing you what Boolean expressions are all about. If we look at the code, you'll see that it's very, very straightforward. Enter someone's age, print out how old they are. If they're greater than or equal to 80, then they're very old. Okay, that's fine. Now, there is a Boolean expression in this code already. Can you see it? Well, probably not, because I haven't told you what a Boolean expression is yet. This is a Boolean expression right here. Age greater than or equal to 80. You can think of a Boolean expression as a condition. When I talked to you about the if statements, I said, if condition, then do some statements. This is the condition. A condition is a Boolean expression, or a Boolean expression is a condition. So what does the word Boolean mean? Boolean means it must be true or false. Okay, that's fairly straightforward. True or false. But now I'm going to explain it to you a slightly different way. Instead of saying true or false, I could say yes or no. I could say on or off. I could say odd or even. I could say up or down. Or I could say 1 or 0. And that's what I'm going to say. I'm going to say 1 or 0. Now, what does that mean? Why would I possibly say that? If age is greater than or equal to 80, okay, yes, true or false, and that's also 1 or 0. Well, of course, 1 or 0 has to do with digital information, but in particular, I want to tell you now, and I want you to understand that this expression that I'm looking at in front of me here, the highlighted words, age greater than or equal to 80, that evaluates to a number that is either 1 or 0. Now, what does that mean? All right. If you're getting confused at this point, I'll show you a more concrete example. Let's create another integer, and we'll call it very old. How about that? And then we'll go down and we'll modify this code such that it looks like this. Very old equals what? Okay, it equals this. Age is greater than or equal to 80. Ooh, hang on a minute. What are we doing here? Very old is equal to age is greater than or equal to 80. Does that even make sense? Well, yes, it does make sense. You can think of very old as almost like a question. If you're reading this as a person, you could say, oh, okay, very old. Is the person very old? So, are they very old, yes or no? Well, the answer to that question is the answer to this question. Is the age greater than or equal to 80? Okay. So, what I'm saying is here, if I'd simply said that, you'd say, okay, yes, I fully understand that. That makes sense. Although the words very old don't seem to make a lot of sense there. That's an inappropriate name for the variable, but it is certainly a workable piece of C code. Well, the plus sign is an arithmetic operator. The greater than sign, or the greater than or equal to sign, is a relational operator. It's still an operator. And if you relate two operands together, age and 80, you will get an answer. That's interesting. What answer will you get? Well, here's what I'm telling you. The answer will be 1 or 0. So the answer to this expression is 1 or 0. So the value that gets stored in very old is the value 1 or the value 0. That's all that very old could possibly have. So now I can do this. This is really going to confuse you. Very old. Well, it'll confuse you if you've never programmed before, perhaps. If very old. Hang on. I'm not comparing anything to anything. There's no condition there. All I'm doing is I'm putting an integer value inside the if statement. If very old. I mean, it might make sense to read from an English standpoint. You can say, if the person is very old, then you can print out that line of code. That's pretty straightforward to read from an English point of view, but doesn't make sense from a C point of view. Well, let's try it. Let's prove that it does in fact work. First we'll compile it. Compile. 0 errors. Let's try and run it. Please enter your age. About 34. You're 34 years old, so we don't get the statement about the fact that we're very old. Let's try it again. Let's sign this side. We're 89. My, you are very old. So we're older than 80 and it seems to be working. Let's try the test case of 80 exactly. 80, and you're very old. Remember, it was greater than or equal to gets considered as very old. Okay, so that works. Okay, so the code is clearly working. Let's take that one step further. Let's put a little bit of a line of debug code in here. Let's try and find out what the value of very old is. Very old equals %d \n. This is going to be displayed no matter whether very old is true or false. Very old. Okay, let's try and run that. Compiles, runs, please enter your age, 34. Very old is 0. Okay, let's try it with the other case. If they're 89, very old is 1. So how about that? Very old is always either 0 or 1. So let's summarize what we're learning here. We're learning that anything that goes inside the brackets of an if statement is actually an integer expression. It's an integer expression. It will evaluate to 0 or 1. We think of it as evaluating to true or false, but it's actually evaluating to 0 or 1. And the 0 or 1 can be tested by actually creating a separate integer and assigning that value to that integer and then testing that variable. That works. So, if you get that, then I'd like to explain exactly what's going on here, exactly what the C compiler does. When you see an if statement, the compiler evaluates the thing between the brackets. It must evaluate to an integer. It must evaluate to some integer value. Now, if you have a relational operator, such as greater than or equal to, or equals or not equals or less than, you can guarantee that the result will be a 0 or a 1. It will be a 0 or a 1. However, I said that it has to be any integer expression in here. Does that mean it's possible to do this? 3 plus 4? The answer is yes, it is possible to do 3 plus 4. That is an integer expression. It doesn't make much sense, but it is an integer expression and it will compile and it will run. So what does it possibly do in this case? Because 3 plus 4 is obviously 7. That's neither 0 nor 1. So what does it evaluate to? Is that true or is that false? It kind of sounds a bit dumb, trying to ask the question, does 3 plus 4 evaluate to true or false? Nevertheless, that's what the C compiler does. It actually evaluates 3 plus 4 and it treats it as a true or false value. It treats it as a true or false value because it's been put inside an if statement. So, this is exactly what happens. 3 plus 4 is not equal to 0. Would you all agree with that? 3 plus 4 is not equal to 0. Yes, of course, because it's equal to 7, and 7 is not equal to 0. Anything that is not equal to 0 is treated as true. Anything that is equal to 0 is treated as false. Let me say that again. Not equal to 0 is true. Equal to 0 is false. And that is very important, very important. Please listen to this. That is the definition of true and false in C. True is anything that is not 0, and false is 0. For simplicity, people often set true to be equal to 1, but it is not necessarily the case. In this case, 7 is true as well, and 115 is true, and 7 billion is true. Anything is true if it's not 0. Even negative numbers, negative 6 is true. The only thing that's false is 0. So what happens if this code runs? It will, no matter what happens, no matter what the age is, it will always print my you're very old, because this expression is always true. It's always 7, and 7 is never 0. Let's check that. Compiles, runs. We enter some small age, 23. It's saying my you're very old. We enter a larger age, 89. My you're very old. It doesn't matter anything. It's completely independent. It will always be true. You could put age there. If age. It's possible to do that. Remember we put very old there. Very old was put inside those brackets, and that was an integer, and age is an integer. So what's the difference? We can put any integer in there. Now, a lot of programmers, you might find this from time to time when you examine other people's code. You might find people doing this, if age, and age is not really a Boolean. See, age here, the variable, we're using that as someone's actual age in the range from 0 to 100. Could be any age in that kind of a range. So we're not really thinking of age as a Boolean. A Boolean is a true or a false, a 1 or a 0, a yes or a no, an on or an off. That's what a Boolean is. But an age is anywhere in the range 0 to 100 or 200 if you're thinking like that. So does that make sense here? No, but people still do it. What are they doing? Why are they writing it like that? Well, what they're actually doing is this. If age does not equal 0. Now, you can see that if age was equal to, say, 50, 50 does not equal 0. That's true. Age by itself, it's 50. And that will evaluate to true, remember, because anything will evaluate to true if it's not 0. So that line is logically exactly the same as that line. Think about that. If you can't see that, just play with it for a bit in your head. Pause the video here and play with that idea. That line is logically exactly the same as that line. Exactly the same. So, I like seeing that line. It makes sense. If age is not 0, you might be saying, well, if you're not a baby that's just been born, then you're very old. And only babies that have just been born are not old. Maybe. That might be what the line of code was written for. So that might be a line that actually makes sense. It might be a perfectly legitimate line of programming code. But many programmers write it like that. Why do they write it like that? Well, because it saves time. It's one less comparison to do. You're not doing the not equal to 0 bit. So it's faster. It is faster. And the program's a little bit smaller, so it takes up less memory. A tiny, tiny bit. That's all true. It is smaller and faster by a millionth of a millisecond. However, it's not so readable. Because when I read that line of code, that if age, it makes me immediately think that age must be some kind of Boolean variable. Now, it's not a Boolean variable, it's an integer number variable, range 0 to 200. So it's immediately misleading me. Now, maybe you think that's my fault. Maybe I shouldn't just assume that's a Boolean. But I like to think that anything that goes inside the brackets of an if statement, if it's written by a programmer that values readability as a virtue of their code, then it's going to be a Boolean. So I'm stating a personal preference here, but I don't like it when people write code like that. Even though it takes longer and it takes up more memory, I would prefer to see that. It's much more obvious what's going on. You go, oh, okay, they're just checking whether age is 0 or not. Even though they're exactly the same. It's just a personal preference. It's a style thing. I just am saying this mostly just to explain to you why you might see programmers do that. They do that simply because it saves time. Anyway, to summarize, I'm going to put very old back here because that's what I'd like to see. To summarize, anything that uses the relational operator, any relational operator, is an expression. It's an integer expression that will evaluate to 0 or 1. That's fact number 1. Relational operators always give a result of 0 or 1. Next, anything that if expects to see inside brackets must be an integer expression. Okay, that's fact number 2. And fact number 3 is that an integer expression that evaluates to anything but 0 is treated as true, and an integer expression that evaluates to 0 is treated as false. Okay, that's it. That's the whole module on Boolean expressions. Hopefully everybody will understand what the C compiler is actually doing here now.